Hello, this is Industrial Control Circuit Troubleshooting 1/4 module. Now we are doing extra skill test number 16. The work order that we received stated that there is no water charged into the tank when start button was pressed. So what's the issue? Let's dive in. As usual, I try to visually check the external device in the circuit to look for any possible trouble issue, and then I will proceed to run the process and observe for any anomaly. Okay, from what I look from the control panel and the circuit wire and all the circuit diagram, all the wiring, I don't see anything wrong. So maybe I can start to run the process by pressing the start button. See, but I don't see any water charge into the tank. However, I see one anomaly where both intake 1 and intake 2 lighting is on at the same time, which is quite abnormal. So what is the issue here? Okay, usually one current only can flow through this parallel circuit and the other current will be stopped at R21. Now what we saw here is both intake 1 and intake 2 lighting on at the same times. But S1 and S2 cylinder valve coil did not energize and no water was charged into the tank. So usually this kind of strange thing happen because of transformer, okay, is faulty. They're giving a low voltage, or there is a loose connection at the common neutral line. When we say very loose connection, it means like no. When we say loose connection, it can be very loose or slightly loose connection. Very loose connection can be treated like open circuit. Slightly loose connection can be treated like a load that having slightly high resistance. So most likely, it can be due to the slightly loose connection. Anyway, we have to check both. Now we check the transformer voltage. Now we set to AC voltage mode, and then we check the transformer voltage. It looks like normal, but at 30 volt, okay. Then now we confirm the transformer, no issue. The second thing we need to check is a common neutral, suspected having very loose connection or open circuit, or slightly loose connection or a load with slightly high resistance. So as we know, the common neutral line is just a wire with lowest resistance. So the voltage, okay, at the common neutral line must be 0. Okay, let's say we measure any voltage across this common neutral. Of course the voltage is 0, or measure voltage at any point at the common neutral line. Example, we measure the voltage at point 2 already lighting. So the current will flow through this path and divided into two paths. Because this neutral line having lowest resistance, which is no different from short circuit, all the current will flow through this common neutral, and none of the current will go through the multimeter. Hence, the multimeter reads 0 voltage. If there is any slight loose connection or a load with slightly high resistance, okay, which we can treat like a normal load inside the common neutral line, what happens is when we measure the voltage here, the current will flow through this line to point 2 will divide into two paths. One path to the multimeter, the other path to the load, or a point where there is a slightly loose connection. So the multimeter will register voltage, but the voltage will be lower than 230 volt AC because there is a load at the common neutral line. So the voltage is divided into two different voltage reading. Okay, so the easiest way to check any slightly loose connection or a load that have a slightly high resistance is by checking from the common neutral line from the transformer side. Okay, I start from the T1X2. Okay, transformer here T1X2, which is connected to TB114 here, TB114. Okay, so TB114. 0 volt is the correct, because the ground point, earth point, is actually connected to the neutral point of the transformer. So the voltage across the neutral line, which is just a wire, the voltage must be 0. It cannot register any voltage. This is the correct one. Okay, now the black probe is at the ground point, which is connected to the neutral point. The red probe we measure at TB114, which is connected to here. The 0 voltage we must achieve the 0 voltage. And this one actually connected to HCB. HCB means heater contactor point B. And then we can connect to here, heater connector point B. 0 volt is correct. And then it connected to TB219. TB219 is here. Okay, then we can measure at TB219 is 0 volt. Okay, good. So TB219 actually connected to drain 2. Here, drain 2 lighting is 0 volt is okay. So this point to here and here. Okay, now is connected to R17 and TB314. Okay, R17, yeah, this is wrong. It's supposed to register 0 volts, okay, instead of 58.6 volt. And then this connected to TB314. TB314 is here. So TB314 is here. It's supposed to get 0 volt instead of 200 volt AC. That means, okay, this 0.19 here have slightly loose connection, or a load with slightly high resistance. You can treat the slightly loose connection as a load here. So when you measure the voltage here, what happens is the current flow through this path is divided into two paths. One to the load, the other to the multimeter. Okay, the multimeter will register voltage, but it will be slightly lower. It will be lower than 230 volt AC. Similarly to here. Okay, 0.14. When we measure the voltage at 0.14, the current from S31 to the solenoid valve 3, then to S332, then to this point, we're divided into two paths. One path to the load, the other path to the multimeter. So it will register voltage. So we assume that we can deduce that we can assume that there is a loose connection at 0.19, dB to 0.19. So we want to check, we have to shut off the power supply. Call the power supply, perform the lockout takeout, and then verify the lockout takeout is done properly. Then we check the loose connection. Yes, there's a loose connection. And then we normalize the lockout takeout, and then we start the process, and the process can proceed as per normal.